In this video, I'm going to show you how to build a production-grade authentication flow with React Native, Amplify, and AWS Cognito in literally 10 minutes. This is a very high-level architectural diagram of what we're going to build. In the first part of the video, I will show you how to build the authentication backend with AWS Amplify in just a couple of clicks. AWS Amplify will set up Cognito backend for us, and will manage the infrastructure as code with AWS CloudFormation. In the second part of the video, I'll show you how to use React Native and Amplify JavaScript library to build the front-end UI in a couple of minutes. Let's get started with setting up the backend with AWS Amplify. First, let's create a new Amplify project. You can click Build an App to create Amplify project for our app. We'll name our project M42. Upon clicking Confirm Deployment, our Amplify project will be initialized. You may need to wait for a couple minutes before deployment succeeds. Once project is created, you can click here to go to the Amplify Studio to manage your project. To set up authentication, we simply need to click Enable Authentication. You can configure how the user can log in, with email, phone number, username, or with social network providers. We'll use the default one to only allow login with email. We'll disable multi-factor authentication for now, and add name as a mandatory field for registration. By clicking Deploy, our authentication backend is successfully set up. Once it's successfully set up, you'll see the instructions to run this command in your React Native app. This command basically pulls the authentication configuration to React Native app so that our app can use this backend for authentication. Before running this in the app, we need to make sure Amplify CLI is set up. For more instructions on setting up Amplify CLI, you can refer to the instructions in the description section of this video. Next, we'll set up our authentication UI with React Native and connect the UI with Cognito backend we just set up. This part is going to be split into 3 sections. In the first section, we'll set up the React Native project with Expo and Native Base. In the second section, we'll implement the user interface in our React Native project. In the third section, we'll connect our front-end UI with Cognito authentication backend by leveraging Amplify client library. Let's get started. We want to set up our React Native app with Expo. Let's get started. This command will install Expo command line interface, so copy and paste. This command will initiate the React Native app with Expo support, so copy and paste. Worth noting here, the command expo init ChatGPT responded is a deprecated command. Usually use npx create expo app instead. Running this command will prompt us to choose a template. We'll choose tabs TypeScript here. It implements a basic bottom navigation tab in the app with React navigation support. Now we have React Native app successfully set up. Let's run yarn iOS to start our app on iOS simulator. You can see that our app is successfully launched. It's a template app with a tab navigation support. Next, we need to set up our UI framework. We'll be using Native Base here. Native Base is a popular UI component library for React Native. It has 18K stars on GitHub. It's a great tool for quickly building production-grade apps with native look and feel. ChatGPT gives me a wrong answer here. It didn't understand that I want to set up Native Base on top of Expo, and it provides an outdated link to Native Base as well. Let's just follow the documentation on Native Base website then. There are 3 commands we need to run, so we'll just copy and paste. Now we have a native base set up. We're going to copy the Hello World example into our app to make sure it's working properly. Let's run our app to validate it's working properly after integrating with Native Base. It worked. Now let's take a look at our UI mockups another time. It may look easy and simple at first, but there are several details that are very important. First, how do we create a button that stays at the bottom of the screen? Second, when the input field is focused, how do we make sure the button's position gets adjusted automatically with a popped-up keyboard? Third, for the phone number screen, how do we make sure to only pop up number keypad? Fourth, how do we make sure the keypad matches our dark theme? We'll be addressing each of them along the way. First, let's create our first screen where user needs to type his or her name and replace the default screen with it when app launches. To create a new screen, we simply need to create a file under Screens folder. We will name it onboarding namescreen.tsx. We'll first implement a simple UI as a placeholder with showing text hello world. Then we'll go to navigation logic to put our screen at the very top. This way, this screen will be launched by default when the app launches. We will create a stack.screen with name onboarding namescreen and with our previously created component. Changing navigation logic will not be hot loaded. We'll need to press R to reload our app in the console to reflect this change. As you can see here, the home screen is replaced by our new screen. As you can see here, the hello world is rendered at the edge of the screen where we can barely see. We can fix that by adding a container with safe area tag. That will make sure our content will be rendered on the safe area of the screen. Okay, now we have the foundation to start work on our UI. Let's lay out the important elements on the screen. First is the title of the page. We'll use hiding component from Native Base. Secondly, it's the input field, and thirdly, it's a button. If we look at the rendered UI, we have all the essential elements on the screen, but it's very different from our target UI. The first thing we need to fix is to place a button at the bottom of the screen. To place a button to the bottom of the screen, we can use flex component of Native Base. Flex has a justify content attribute where you can use spaces between. It will add spaces evenly between the children elements. As button is the last element, it will be positioned to the very bottom of the screen. As you'll notice here, as we have heading, input, and button as three children elements, those are split evenly. But we want the title and the input to stay at the top of the screen. To achieve that, we can group heading and input together with a VStack, and button within another VStack. As you can see now, heading and inputs are at the top of the screen, where button stays at the bottom. When the input field is in focus, the virtual keypad will pop up, and it hides the continue button. This is a very bad user experience, so we need to make our UI to be adaptive to keypad pop-ups. There is a keyboard avoiding view in React where we can leverage, so we'll just wrap our component inside a keyboard avoiding view. Now you can see here, as the input is in focus, the button will automatically adjust itself, move to the top of the keypad when it's popped up. Next, we'll customize the look and feel of each component. To make it reusable, we'll create our own component for each of the native base components we used. So we'll have M42 hiding, M42 button, M42 input, and M42 brand components. They're just a wrapping of the corresponding native base components. First, let's change the background to black and add some paddings. With black background, the hiding text is invisible. Now let's customize the hiding. We'll go to M42 hiding.tsx. We set in color to white, font size to 20, and margin bottom to 5. Now the hiding is the same as our mockup. Now let's customize input field. Let's go to M42 input component. With removing the border by setting border width to 0, to increase the font size to 35, make the placeholder text align with our heading by removing the padding, and setting the font weight to bold. Now we will customize the placeholder with changing the text color. The blue blinking cursor is hardly visible, so we'll change that to white by changing selection text property. Now let's customize the M42 button component. We'll need to change the background to white and button text to black. With adjusting other properties, we finally get our button UI ready. The last part is to customize the brand logo. I have created the logo as a PNG file, so I just use an image component with referring to the PNG. To make the logo show up in the middle, we'll use the center component to make the alignment. We're setting up the margin bottom. Now we have our UI properly implemented. The other screens has a similar layout, so skip the other screens here. It will be very similar to what we have implemented so far. Now let's connect Cognito backend with our front-end UI. Amplify provides extremely simple APIs for us to communicate with Cognito Authentication backend. Let's take a look at the authentication APIs we will be calling from our React Native app. Sign-up API will sign up a user with username, password, email as arguments. Upon calling this API, Cognito backend will sign up the user and send an email with confirmation code. Resend sign-up API will send a new confirmation code in case user didn't receive one. Confirm sign-up API verifies customer's confirmation code so that we can verify customer's email address. If we enable auto sign-in, the sign-up function will dispatch auto sign-in hub event after successfully confirmation. If auto sign-in failed, it will dispatch auto sign-in failure event. We can subscribe to those events to enable auto sign-in after registration. Okay, let's dig in. Before making any changes in our React Native codebase, let's first set up Amplify in our React Native project. You can run this command to install the required dependencies from the root of our app. As I already ran those commands, I'll just skip this section. I'll add this link in the description of the video as well. Then we'll run the command when we set up our authentication backend. Copy and paste. With authenticating via Amplify web interface and answering a couple of simple questions, our Amplify client is set up. Now let's get started with some coding. First, let's copy Amplify configuration code into apps.tsx to initialize Amplify. Once that is done, we can go ahead and implement user sign-up logic. Remember, we have 4 screens to implement. The first screen asks user's name. The second screen asks email address and registers user by calling Amplify sign-up API. The third screen asks user type the confirmation code sent to user's email address and confirms with calling Amplify confirm sign-up API. And the last screen finishes the sign-up by asking user to create a username. We'll skip the first screen as it's going to be a very simple implementation and focus on the second and the third screen. Let's get started with the second screen. Let's take a look at the user experience. 2 things to note here. First, we want the button to stay disabled and not clickable until the user types a valid email address. Second, upon clicking the button, where we are calling our Cognito backend, we want to disable the button and change the text on the button to registering to indicate in progress status. We will navigate to the email screen we previously implemented. Let's first copy the sign-up API into our page. This is the function we'll be calling to register a user. As we use email as a registration verification method, email address will be mandatory. User's name is another mandatory field we explicitly asked on the first screen. The sign-up function we created takes 4 parameters. We'll use user's email address as username, and we will generate a random password for the user, and we will also disable password login from the backend. For user's name, we will use the name passed from the first screen. We will not ask user to create a password. Our login will not ask user to type the password neither, but instead, we will send a verification code to user's email address to allow passwordless login for the user. Email address is typed and submitted by the user. We use React Hook Form library to handle form submission and validation. It has 32 key stars on GitHub, and it's proven to be performant and developer-friendly. First, we have to install the library with yarn. with this very simple command. Now just need to copy React Native example from React Hook Forms documentation to our onboarding email screen. Copy the input, paste, copy initialization code, paste, copy onSubmit function, paste, copy the use of the controller, paste. There are several things we need to change here. First, in the original render function, it uses text input to render the input, where we have our customized M42 input, so we'll replace text input with our component here. Secondly, if we take a look at onSubmit function, there's a type script error. To fix that, we can define our own type for our form. Here we will define a new email form type and use email form type when calling useForm. Now let's write onSubmit function more properly with our predefined type. Last but not least, we need to add onPress handler to submit the form and call our onSubmit function when user presses the button. Now we have the form handling logic set up. Let's write up the onSubmit function to actually sign up the user when the button is pressed. When user clicks the button, we'll call signup function to register the user. Note it takes 4 parameters: name, username, password, and email. We know the email address and username as they are the inputs from the form. For password, we'll write a placeholder here to generate a new password. And for the name, we have a previous screen where the name is passed in as a parameter to the route. So let's just get the value of the name parameter passed along with the route. And use that in the code. For password generation, I already wrote a util function to do that, so just replace our placeholder with that function. Okay, we're almost done here. Now when user clicks a button, we'll register a user in our Cognito backend when we created it at the beginning of the video. To test that, we'll add 2 log lines in our signup function. When the user is successfully signed up, we'll log the user, and when there's an error, we'll log that error instead. This is our Cognito backend. Currently, we have 0 registered users. If the registration succeeded, we should be able to see 1 registered user. Okay, now let's launch our app. Type our name and email address. By clicking Continue, it will call signup function and sign up the user. If they succeed, we'll be able to see 1 log line that logs the user info. Otherwise, we'll see an error message. Let's switch back to our console. Okay, as you can see here, it logs the user info, which indicates the registration succeeded. Let's go back to our Cognito backend page. Refresh the page. Now we can see we have 1 registered user. Okay, registration is working. The only thing left is to adjust some UX. We want to achieve the following as we mentioned previously. First, we want the button to stay disabled and not clickable until the user types a valid email address. Second, upon clicking the button, where we are calling our Cognito backend, we want to disable the button and change the text on the button to registering to indicate in progress status. To disable the button until the input is valid, we can create a React state. The variable is valid here indicates whether user input is a valid email address, and set the default value to false. In M42 button component, we'll set is disabled to not is valid. Now if we go back to our app, the button is disabled by default, as the isValid is set to false by default. Now we need to implement the logic where we change isValid state to true when user input is a valid email address. That can be done via the onChange text event. Every time user input changes, we'll call the function to validate whether user input is valid email address, and set isValid to true when it's a valid email address. Okay, now let's take a look at our app. The button stays disabled until we have a valid email address. Similarly, we're going to create a React state is loading and set is loading to true when we call our signup function, and set is loading to false when signup function returns. And we will update our button to user state with setting is loading to is loading state, and setting is loading text to registering. In this way, the button will be in is loading state when we are signing up the user. Okay, that's all we need to implement for authentication. For the email verification screen, it's going to be very similar to what we have implemented so far. So we'll skip it here. If you like this video, please do click the like button. And if you like programming and are interested in building iOS Android app for both backend and front-end development, please do subscribe to this channel. Thank you.